lecture is not enough to make a day, but your smile can. So start this lecture with a smile. So let's get started. We are going to calculate twisting couple on a cylinder. So first we are going to calculate twisting couple for a solid cylinder. So here I have taken a solid cylinder. We know that a solid sphere is made up of large number of hollow spheres. I had told you that analogy with jawbreaker candy. Similar way, a solid cylinder is also made up of enormous number of what you call is hollow cylinder. So if I take a point here on the upper surface, I have just fixed its upper surface, and lower surface is free to rotate, means twist, and I am applying a twisting couple on its lower surface. So it will twist, upper end will be fixed. Let us suppose a point be A here, and parallel, drawing a line parallel to OO dash, I will get a point B. But after the application of the couple, B shifted to B dash, but A is fixed. As you know, the upper surface is fixed. So now this angle is the shear. As if stress is being applied, a shear will be there, and the angle traced by B is theta. As B is shifted to B dash, it makes an angle theta with its initial position. So let us suppose this thing to be of length L. Here we can take lot of what you call is hollow cylinder to make it up. Consider it to be one of them. If it has the radius of x, then you can see that x theta will tell you about the length of arc BB dash. We know that the angle into the radius will give the length of the arc BB dash. Here is making an angle theta and radius x. So BB dash will be equals to x theta. But from this we can see that L, the length into the angle, will also give the BB dash, means L into phi is also equals to BB dash, means x theta is equals to L phi. So phi will be equals to x theta by L, means this is the shear. So now we have the shear. We know about shear, what you call is modulus of rigidity, eta. Eta is equals to shearing stress by shearing strain, or we simply call it shear. So the shearing stress will be equals to eta into the shear phi. So this will be equals to eta into x theta by L. Here we have the stress, we can calculate the force. So let us suppose we have considered this cylinder to be of, this elemental cylinder to be of radius x. Remember that I am calling it elemental cylinder because the actual cylinder is a solid cylinder, and we are just talking about a hollow cylinder, just the element of that cylinder. We have considered that the solid cylinder is made up of many hollow cylinders, and have taken this one in particular where the radius is x. So this is an element of that big cylinder, not the cylinder for which we are calculating this. So for this elemental cylinder, here is the stress. We can calculate the force. Now we have phi equals to x theta by L. If I just open the cylinder, means if I take a blade and cut it along the line AB, then I will get a rectangle looking something like this, A, B, C, D. And after the application of couple, B shifted to B dash, D shifted to D dash, making a shear of phi. Now I have this shear. We know that modulus of rigidity is shearing stress by shearing strain. So we can calculate the shearing stress by multiplying shear with rigidity, modulus of rigidity, which will be equals to shearing stress equals to phi into eta, which will be equals to eta x theta by L. Now we have the stress. I can calculate the force as here. If I take this elemental cylinder, I have taken the elemental cylinder as a hollow cylinder, as I had already told you about that how if I consider a solid sphere, it consists of a large number of hollow spheres, and when I take the radius of the hollow sphere to be really very small, then it will look something like a solid sphere, means just look like a mustard seed. And if I cover it with more and more number of hollow sheet of hollow sphere, it will finally make a solid sphere. Similarly, if I just take a hollow cylinder, yes, hollow cylinder of radius nearly equals to 0, it will look something like a graphite in your pencil. And if I just dip it in more and more amount of some substance of which I want to make a cylinder, then it will finally result into a solid cylinder. Means it has a lot of layers of what you call is a hollow cylinder. And I am just showing you a exaggerated view of that hollow cylinder, because I have here shown you a hollow cylinder of large thickness, but we just assume it to be nearly very small, like and just dividing the solid sphere into infinite numbers of hollow spheres. Like you know that cookie cutter, you just take a bigger one, cut it, take a smaller one, cut it, and just use smaller and smaller cookie cutter, and then you will see that a large number of that circle is actually making the whole circle. Large number of what you call is a ring is making that disc. In the similar way, you can also understand the cylinder. In case you have some doubt about this, you can also comment it. I will try to solve it. And here you can see that dx is the what you call it, dx is the thickness, yes, and its perimeter is 2 pi x. Because I have considered it to be elemental solid hollow cylinder of radius x, and now 2 pi x dx will be this area. The force is being applied along the lower face, so I will obviously use this area. So the force will be equals to eta x square theta 2 pi dx by L. This is the force. And if we want to calculate the couple, we have to just multiply the force with its perpendicular distance, where perpendicular distance is x. So the couple will be eta x cube theta 2 pi dx by L. Now I have to integrate this from 0 to r, because initially I am going to take a very small, very not small, very slim cylinder, where if even it is really hollow cylinder, but will not look so, because we will not be able to see that there is a hollow space inside it. And if I integrate it, I will get eta theta. And let me first erase this. I will write it on the top so that our result will look clear. So this is the thing. So if I integrate it, I will get x. I have to only integrate x cube, because all other things are constant for it. And if I integrate x cube, I will get x to the power 4 by 4, and by 4 will be cancelled with I can divide 2 by 4 and say it to be equals to 1 by 2, and finally I will get eta x here. I have to put the limit for x to the power 4, where I will put the limit from 0 to r, means r to the power 4 minus 0 to the power 4, which will be equals to r to the power 4 theta. 2 will cancel with 4 and will remain with 1 by 2l. You can write it more beautifully by eta pi theta r to the power 4 by 2l multiplied with theta. This is couple. So this is the couple, and we are going to calculate torsional rigidity, means couple per unit twist. Means if theta will be unity, what will be the couple, and that is denoted with C. And if I replace theta with 1, I will get eta r to the power 4 by 2l. It is also called torsional rigidity, and you will also use this concept in galvanometer, means it is highly used concept. So here it is actually telling you about how rigid the substance is. If I am taking this string or this cylinder, if C is high, then it will not just bend easily. That's why I am going to tell you another topic. So just write it down. I will come to this topic once again. So now I am going to consider a hollow cylinder. For hollow cylinder, I just have to change the limits from, I had the thing as eta x to the power 3, sorry, the thing was eta pi eta, sorry, 2 pi eta and theta by 4l into x to the power 4. Here for a solid cylinder, initially the inner radius was 0, but for a hollow cylinder, let it to be r1 and outer radius to be r2. Like if this is a cylinder, hollow cylinder, its inner radius be r1 and outer radius be r2. Then I can simply put this limit and I will get pi eta theta by 2l into r square r to the power 4 minus r1 to the power 4. If you remember this, you can just substitute r to the power 4 with r2 to the power 4 minus r1 to the power 4. And now I have this, and so I can also calculate the torsional rigidity. Let it be C dash, so that you will not confuse C with C dash, and just divide theta. You can actually, this is couple for couple, the couple applied to turn it by angle theta, right? Means theta was the angle when we applied the couple, and if I want to calculate couple per unit twist, I have to divide it by the total twist, and if I divided this thing by twist, I will get the torsional rigidity or twist per couple per unit twist. Both the things have the same result but have a different point of view. So we can say torsional rigidity will be equals to 2 pi eta 2 by 2l r2 to the power 2 to the power 4, sorry, r1 to the power 4. And now you can see that I have C and C dash. Now I am going to calculate the ratio of C dash by and C. See if the if suppose I have ore of iron and I want to make a shaft for my machine, which will just transmit some torque, and suppose like that of turbine, and if my machinery is actually need to work with some torque and have to transmit torque, then I will need a shaft, and to get a beautiful shaft, means which will work efficiently, I have to calculate the torsional rigidity. I have the mass constant, the material constant, and I am going to calculate thing. Means I should make a shaft of solid cylinder or make a hollow, that of hollow cylinder. The answer is obviously a hollow cylinder. But why? Because I am going to calculate it mathematically, but I am telling it, if I just find the ratio of C dash by C, then I will find that C dash is greater than C. Means the couple, if I couple per unit twist, A will be large, C dash is large, means couple per unit twist is large. Means to just twist it by a unit angle, you will need a greater torque. But here the torque, with a smaller torque, it will just twist by angle of unity. And I don't want that my machine will look twisted after I turn it on. So I will prefer a hollow shaft. So you can divide C dash by C and we will get R2 to the power 4 minus R1 to the power 4 by R to the power 4. Let me first erase this thing, yeah, so that I can calculate that volume thing and all. R2 to the power 4 minus R1 to the power 4 by R to the power 4. Here the mass is same, so density into volume will be same. As the material is same, density will cancel out, means volume of the hollow cylinder will be equal to volume of the solid cylinder, which will be equals to 2 pi r square, let the length be L, equals to 2 pi r square r2 square minus r1 square into L. 2 pi L will cancel and r square equals to r2 square minus r1 square, right? Now I can say that r square plus r1 square equals to r2 square plus r1 square, r2 square simply. And if I again add a r1 square, I will get r square plus 2r1 square equals to r2 square plus r1 square. Okay. So now if here I just say, I can say it to be r2 to the power 2 minus r, because I can say it to be r2 to the power 2 to the power 2. So you know that a square by b minus b square equals to a minus b into a plus b. So I can write it in a similar manner, r2 square minus r1 square whole into r2 square plus r1 square by r square, r to the power square, r square into r square will be r to the power 4. I know that r square equals to r2 square minus r1 square, means this thing will cancel, this is a plus sign. So I have now r2 square plus r1 square by r square. Here I can see that this thing is equals to this thing plus this thing. So I can write r square plus 2r1 square, because r2 square plus r1 square equals to r square plus 2r1 square. So this thing equals to this thing by r square, which will be equals to 1 plus 2r1 square by r square. I wouldn't know about this time, but we can simply say that 1 plus something, 1 plus, even if it is a number in fraction, it will give a number greater than 1, means the ratio of C dash by C is greater than 1. Means if I take C to be to right hand side, I can see that C dash is greater than C, means the torsional rigidity of the hollow cylinder made up of the same materials having the same mass will be greater than that of the solid cylinder made up of the same material and having the same mass. So we will talk about some topics on this in the next lecture. Thank you.